Hi everybody, I hope you're doing well. Today we're going to talk about the mole ratio. The most important thing you need to remember about a mole ratio is that you need a balanced chemical equation. The coefficients in a balanced equation are what you use to make up the mole ratio. They show the relationship between all elements and compounds in an equation. You can use the balanced chemical equation to tell you all kinds of stuff. The one we are most concerned about today is this one right here. The ratio of moles of each reactant and product in a reaction is the mole ratio. The mole ratio is the ratio between any two parts of a chemical equation. So you use the coefficients in a balanced equation, and mole ratios let you compare reactants to another reactant, a reactant to a product to a reactant, a product to another product. You can move anywhere in an equation. You don't have to go from reactant to product. Once you determine the ratio, you can set up the conversion factors. Okay, so we're going to take a look at this equation here. C3H8 plus 5 moles of O2 produces 3 moles of CO2 and 4 moles of H2O. And we're going to talk about setting up some mole ratios. Mole ratios can compare any two parts of an equation. When you write the ratio, the two numbers are separated by a colon. You use the coefficients and you write them in the order given in the question. So now we've got some examples. We're going to compare C3H8 and we're going to compare it to CO2. If there is no coefficient, just a quick reminder, that's a 1. So in this case, we have C3H8 and CO2. C3H8 does not have a coefficient, so it's 1. CO2, there's 3 moles, so your ratio is 1 to 3. For O2 to C3H8, again, C3H8, no coefficient, so it's 1. Oxygen has a 5. The 5 comes first, so it's 5 to 1. O2 to H2O, 5 to 4. And then I went through the rest of the equation because I want you to understand that you can move anywhere inside the equation. In this case, we're comparing a product first backwards to a reactant, which is O2. So CO2 to O2, 3 to 5. Water, which is a product, to carbon dioxide, which is also a product. So water to CO2. Doesn't matter. Water comes first, 4 to 3. And then the last one, we're comparing a product all the way back to a reactant. It does not matter. So in this case, it's 4 to 1. Okay, so once you have a ratio, it can become two conversion factors. Mole ratios allow chemists to move around from one compound to another in an equation. So in the equation from the example just back there, we're going to create the conversion factors for CO2 to O2. Remember, the ratio was 3 moles of CO2 to 5 moles of O2, which means 3 moles of CO2 are produced when 5 moles of O2 react in the equation. It gives you two possible conversion factors. The first one puts carbon dioxide on the top, so 3 moles of CO2 over 5 moles of O2. Or you just flip it over, 5 moles of O2 to 3 moles over 3 moles of CO2. You determine which factor to use based on what is given in the equation. So our possible conversion factors, we're going to continue the same example. I can have moles of CO2 on top or moles of CO2 on the bottom. The question I've been given is, how many moles of CO2 will be produced if 12 moles of O2 are reacted? The first thing you do every time is write what you're given. So in this case, I'm given 12 moles of O2. Then you choose your conversion factor. The way you choose a conversion factor is whatever you need to get rid of or cancel out goes on the bottom. So because I'm given O2, O2 has to end up on the bottom. So it's going to be 5 moles of O2 on the bottom and then 3 moles of O2 on the top. And then you simply solve. So in this case, it would be 12 times 3 divided by 5. I suggest you remember to hit the equal key. So 12 times 3 equals divided by 5. And your answer comes out to be 7.2 moles of CO2. Okay, so now we have one last example. We're going to work with the exact same reaction. We're going to work with a different ratio. So this one is how many moles of H2O are produced when 6 moles of CO2 are produced. So this time we're only working from the reactant end. Does not matter. We would go back to our ratios, and the ratio of H2O to CO2 was 4:3. That gives us 2 possible conversion factors, 4 moles of water on top and 4 moles of water on the bottom. CO2 on the bottom or CO2 on the top. We decide that based on our question. So the first thing you do every time is write what's given. In this case, given in the question is 6 moles of CO2. Whatever is given, that's what should be the bottom of my conversion factor. So if I have CO2 given, CO2 must be on the bottom of the conversion factor. So my conversion factor would be 4 moles of H2O over 3 moles of CO2. Once I have that set up, all I have to do is solve. My moles of CO2 cancel out. I'm left with moles of water, and that's what the question asked you for. It says how many moles of H2O. In this case, it'd be 6 times 4. Remember to hit the equal key and then divide by 3, and that gives you 8 moles of H2O.